Hi there, my name is Joseph Tooby-Smith and I'm going to share an insight into my past, current and future research. Please bear in mind that the video you're about to watch is very much a work in progress and I'm eager to hear your thoughts and suggestions on how it can be improved. I believe in the power of collaboration, so if you do see something in this video for which you're like, hey, this looks cool, or hey, I work on something like this, and you want to collaborate, please do get in touch. So without further ado, let's begin. Allow me to begin with a brief overview of what I often refer to as the roller coaster of my academic career. The ride started in 2014 in Oxford. For the next 4 years, I immersed myself in a library, working to obtain an integrated master's in mathematical and theoretical physics. In 2018, the coaster moved laterally across the UK, taking me to Cambridge. Under the guidance of Ben Pears, I undertook my PhD titled Arithmetical, Geometrical and Categorical Forays into Particle Physics. In simpler terms, I was applying mathematical concepts to the field of particle physics. Come 2021, the coaster makes a sweep across the Atlantic to Cornell, where I began my first postdoc. This is where I currently reside. As illustrated by the photos on this slide, my life isn't all academia. I love the great outdoors, running, hiking, kayaking, and climbing. So with that glimpse into my background, both academical and personal, let's delve into my research. In the diverse tapestry of my research journey, I've traversed 3 distinct terrains. Firstly, there's phenomenology. With 4 papers under this umbrella, my focus was on crafting models for experimental comparison. My work here has given me a deep insight to the aspirations of the phenomenological community. But as my personal interests have evolved, I've moved away from this area. Next, we have mathematics applied to phenomenology. This segment of my journey delved into the intricacies of Lie algebras and number theory and the applications to gauge extensions of the Standard Model and other gauge theories. This too has become a chapter in my past. Finally, we arrive at a domain that beckons both mathematics and formal high-energy physics. It is here that my current and future aspirations and research lie. I'd like to spotlight 2 of my papers within this domain, products of a collaboration with Ben Pears and Oscar Randall Williams. Let's delve deeper into these works. In these papers, we transverse the realms of invertible generalized symmetries, using inputs from topos theory and algebraic topology within the framework of functorial field theories. Our first venture explores the landscape of discrete invertible generalized symmetries within topological field theories. Here we've defined these symmetries and given a classification for 1D and 2D TFTs. In the 1D realm, we get, for example, projective representations, as anticipated from quantum mechanics. Furthermore, this study delves into the intricacies of gauging these symmetries, drawing connections to the field theory's locality and unveiling various different types of drift anomalies, some of which were previously unknown. Venturing further, our second paper brings us closer to the physicist world. It rigorously tackles smooth, including Lie, generalized symmetries of dynamical quantum field theories, building upon the work of Grady and Pavlov into QFTs as functorial field theories. Through precise definitions and analysis, we recontextualize some classical results. For example, that d-dimensional theories are restricted to at most d-1 form symmetries, albeit with the nuanced intricacy that one may have certain types of d-form symmetries for d-dimensional field theories. We also introduce a novel type of anomaly occurring independently of gauging. This anomaly speaks to the potential that a theory symmetry may not extend smoothly across the entire landscape of theories. We've termed this anomaly a smoothness anomaly. I find the beauty of these papers lies in their symbiotic relationship with with both the mathematical and physical worlds. Our definitions of symmetries resonate with the mathematical community's expectations, whilst concurrently aligning with the physicists' anticipations. The two papers we've discussed serve as a cornerstone for my future research pursuits, which are collated into 5 distinct objectives. Firstly, I aim to journey deeper into the realm of smoothness anomalies. This will involve exploring their genesis and deciphering their implications to physics. Secondly, when we think of a symmetry through the physicist lens, it often manifests as a group action on entities like a target manifold or other foundational structures. I'm set on formalizing this process for functorial field theories and connecting to the definitions of symmetries elucidated in our recent publications. The third objective takes us to the heart of classical mechanics. In particular, how do we formalize the process of integrating out a field of a path integral within the context of functorial field theory? Integrating out fields serves as a different pathway that physicists use to eliminate background fields in theories, and it's used in abundance by phenomenologists. In light of our exploration of invertible symmetries, it's only natural to wonder, along a similar lines, is it possible to rigorously study external, non-invertible symmetries within functorial field theories? This serves as my fourth objective. Lastly, with our dive into smooth symmetries in the second of the papers discussed, a natural question arises. What does Noether's theorem look like within the context of these smooth symmetries? This forms the crux of my final objective. Embarking on this research journey demands an interdisciplinary approach, harmonizing tools from both mathematics and physics. On the mathematics front, I foresee employing techniques from Lurie's higher algebra and intricacies of differential cohesive topi. As I draw this video to a close, I want to extend my thanks to you for taking the time to watch this video. Should you wish to discuss any aspect further, collaborate, or simply share your thoughts, I warmly invite you to reach out. My contact details are on my website, and I would be delighted to hear from you. Thank you once again.